All right, the last topic we're going to cover in class is what's called polar coordinates. Um, when dealing with polar coordinates, every day that you've walked in here, you've walked in this room and you went past what it looks like Spidey's web back here. Spider-Man spinning some webs here and shooting some webs back there. You got Spidey's web back there on the back board for those that sat and went to Spider-Man this over the Christmas break. You got Spidey's web back there. Well, that is called a polar coordinate system. And when you're dealing with graphs and the graphic ideas, you have the Cartesian coordinate system, which is what you've dealt with throughout your algebraic career. You had an x-axis, you had a y-axis, or we had theta axis and we had a y-axis. Okay, that's what you're typically used to. When dealing with polar coordinates, sometimes it's easier to graph things dealing with polar coordinates than it is dealing with Cartesian x-y coordinates. A lot of the old school graphics on computer games, okay, the computer games that are being played out there, the graphics that used to go into those things were all done with polar coordinates because it was a lot easier working with the polar coordinates to be able to find values that you can graph than it was in an XY coordinate system. And you'll see today as we go through a couple of the polar coordinate equations. So if we take a look at what we have here in Spidey's web. Okay, we have this point right here, which is called the pole. This is the pole. Think of it as if you were looking at a globe, the top of a globe, this would be the North Pole. Then as you look at that globe with the North Poles, you have longitude and latitude lines that go from the North Pole downwards and continue to have the circles as you go down also. That's what these lines are like. So if you could take this paper off and sort of wrap it around the globe, what you would have is you would have the northern hemisphere, basically. You'd think about this as a pole, and I wrap this down. This gives me my northern hemisphere. We have our degree lines, which takes us back to what our normal degree lines were. We have our 0 degree here, and we can rotate around. These are hashed out every 15 degrees. We have 30 degrees, we have 60 degrees, we have 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210, 240, and then we would go back to 360 degrees here. Every line there is every 15 degrees. I'm just going to mark the 30, 60, 90s, 120s. Now, when we're dealing with two-dimensional graphing, we have an XY coordinate system. We know that we need to have an X value and a Y value. Well, we don't have X values and Y values here with this graph. What we have is we have what is called R's and thetas. Your theta is your angle of rotation, and your R value is the distance from the pole. Your theta is your angle of rotation, and your R value is what is your distance away from your pole. Well, how do we measure distance away from the pole? Well, that's where these little circles come in. Because by definition, a circle is a set of points, set of coplanar points that are equal distant from a given point. Well, the given point's going to be the pole. Bless you. Each one of these circles are going to be equal distance. These points are going to be equal distance from the poles. Now, you can label these circles as you want, as you need. What I'm going to do is every other one I'm going to label as a unit. So this is a half unit away from the pole. This is 1 unit away from the pole. This is a unit and a half. This is 2 units away from the pole. This is 3 units from the pole. If you have a graph that you may have to deal with that takes you out to bigger values, you might have to label them every 2 or every 1 being 1, 2, 3, 4, 5, 6. But you can just label these circles, and this signifies on this circle, every one of these points is 2 units away from the pole. And that's by definition of a circle. So what we're going to take a look at is we want to plot these points. We want to plot the ordered pair 230. Well, first off, our ordered pair that we deal with here is, your ordered pair is r theta. Your r value comes first, your theta value comes second. And we want to graph the ordered pair 230, which means our r value is 2, and our theta value is 30. Now, you could do this either way. It does not matter. You could go to the 2 circle first and then rotate up 30, or you can rotate up 30 first and then count out 2 units. It doesn't matter. It's like an XY coordinate system. I could go up y and over x, or I could go over x and up y. Doesn't matter which direction you go. So I'm going to rotate 30 degrees, and I'm going to count out 2 units. So here's my 30-degree line. This is 1 unit. This is 2 units. This would be the ordered pair 230. Or if I want to sit there and say, okay, I'm going to go out to the 2-unit line there, and then I'm going to rotate around until I get to 30 degrees, that is fine also. Whatever works for you. Okay, go ahead and plot the next 3 points. Check your answers and locations with somebody around you. The first 2 should be easy to do. You got 120, and on the line of 3, we have 3 120. Then we have 1 210. The question is what do we do with -3 and 300? Well, if I ask you to graph the ordered pair -2, 3, and the ordered pair 2, 3. If I ask you to graph the ordered pair 2, 3, I would go to the right 2, then I would go up 3. This would be the ordered pair 2, 3. Negative 2, 3, which direction would we have to go? Right, to which direction would you have to go? To the left. We go the opposite. If I was positive 2, I go to the right. When I throw the negative in there, I go once again, SpongeBob opposite day, I go the opposite direction to negative 2 and then up 3. So this would give me my negative 2, 3. Well, when I have negative 3, 300, if I looked at the ordered pair 3 and 300, if I gave you that ordered pair, you would go to the 300 line, go to the 300 line and go out 3. That would be the ordered pair 3 and 300. I go to the 300 line, go out 3. If I have a negative 3 there, what do you think we should do with the negative 3? Which direction should we go? Okay, we go the opposite direction. So we'd go out which line? Which line would we go out? 300 takes us this way. If I go the opposite direction, 120. I would be going out this direction right here. So this would be the same ordered pair as 3 and 120. Sometimes when I have this, because my eyes are old, I have to put a straight edge up there to make sure I go out the correct line. If I would hold a straight edge down here, this takes me out to positive 3. I have to go the opposite of that, so it takes me out the opposite direction. Like I said, sometimes I have to put a straight edge here to make sure I go out the right line. So it tells me to go out from this point, rather than going positive 3 on the 300, I have to go negative 3, which takes me out to 120. Just takes us the opposite direction. Just like this takes us the opposite direction here. Well, let's take a look at what we're going to do with respect to a graph. And we can label these. There we go. We can label it just as we did in the front. What we want to be able to do is we want to be able to graph the equation r equals 1 plus 2 cosine theta. Now, there's no easy way of going through graphing the polar coordinates. Not like when you have y equals 2x plus 3. We learned, yes, we could get all our x and y values and plug in x off from y, get the ordered pairs. But then we looked at y equals mx plus b. A slope of 2, a y-intercept of 3. We can put a point at 3 and go up 2 to the right 1. We don't have that type of easy way of getting through polar coordinates. So all we can do is we can sit here and we can go through and calculate values. So what I have here is I have a bunch of theta values. We have a bunch of theta values here. My equation is 1 plus 2 cosine of theta. You're going to have to go to your calculator and type in 1 plus 2 cosine of 0, 1 plus 2 cosine of 30. 1 plus 2 cosine of 60. Go to 1 decimal place, that is fine. Just go to 1 decimal place. You want to find all your R values. Then from there, this is going to give you an R theta ordered pair. So you're going to find these R values. You're going to graph each one of those ordered pairs. Don't connect them yet. Don't connect them, but you can plot all those ordered pairs. Theta is degrees. Once again, you can plot the ordered pairs that you come up with. Don't connect them yet, though. Okay, if you take a look at the R values, Laura, what's your R values? Just read down your column. 2.7. Okay, so applying these points, at 0, we are at 3. At 30, we are at 2.7. At 60, we are at 2. At 90, we are at 1. At 120, we are at 0. At 150, we are at negative 0.7. So we have to go out the negative line to 0.7. At 180, we are at negative 1. At 210, we're at negative 0.7. Then we go back to 0. Then at 270, we are at 1. At 300, we are at 2. At 330, we are at 2.7. And at 360, we're back up at 3. Now, the question is, how do we graph, or how do we connect the dots, here? Okay, how we connect the dots is we have to go in numerical order according to the degrees. So we have to go from 0 to 30 to 60. Now, this is not going to be a straight edge with a straight line. This is going to be curved. So we're going to go from 0 to 30 to 60 to 90 to 120. And we're going to continue on. Oops, I missed one there. We're back to 0 then, and then we're going to continue the rest of our. Once again, this is not a straight edge type of graph. This is a curved graph. And what this graph is called, this is called a lemicon with a loop for you Irish people. Because we have a loop in here. They also have lemicons without the loop. So they, once again, you have different types of graphs. You have something called a cardioid, which is more like a heart, what a heart would look like. 3-leaved rows, 4-leaved roses. Now, to take a look at this equation, this was pretty easy to put values of theta in and solve for r. If I would take a look at this in an xy coordinate system, this will take me a second. In an xy coordinate system, this equation would be x squared plus y squared is equal to the square root of x squared plus y squared plus 2x. Okay, if I take a look at the complexity of this equation compared to the complexity of this equation, this is a lot easier to work with than dealing with a lot of square roots in there and a lot of squares. Okay, it's just a lot easier to work with. So it's a lot cleaner to work. So dealing with curvature, when you're dealing with curvature and graphs, sometimes it's a lot easier to deal with the polar coordinate system. Now what you have for homework is on page 273. You have problems 1 to 8. You have problems 1 to 8, and then you have 9, 11, 13, 16, and 21. Problems 1 to 8, all that you're doing in problems 1 to 8 is you're graphing some ordered pairs. What you want to do is the first 8 problems, the graphing of the ordered pairs, the practice of that, do it on one graph here. Do on just one of these graphs and just label all the ordered pairs. Then problems 9, 11, 13, 16, 21, you're going to want to do each one of those separately on the graph. Now, when you get to the 3-leaved rows and the 4-leaved rows, most of your graphs you'll be able to go 30, 60, 90, 120, and so on. But what happens with the 3-leaved rows and the 4-leaved rows is if you use 30, 60, 90, 120, you're going to go from here to 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 here, and this will just continue to repeat itself throughout the entire 0 to 360. What you have to do when you start getting something like that is throw in some intermediate values, which is your 15s. But what you'll be able to do is stop at 180. You won't have to go throughout the entire 360. So you have to, yes, do some intermediate values. You'll double up the number of values you have to do, but then you only have to do up through 180. And what that will do is that when you go through this graph, that will give you a point here, which will give you this, a point here, which will give you this, a point here, and a point here, which will give you this. Okay, so we'll give you that 3-leaved to 4-leaved rows. Just the rows is you have to worry about that. The cardioids and the lemicons, the 30, 60, 90, 120s, you'll be able to do and get your ordered pairs a lot easier with those. questions you have. Okay, tomorrow we're going to work on conversions. We'll work on this tomorrow. How to convert a polar coordinate to a Cartesian and Cartesian back to polar. That's what we'll work on tomorrow. The in-class assignment on Wednesday will be a combination of both of these things put together. Sort of like an open book quiz is what it will be. You can use your notes and I'll be fine with that. We just need to make sure we get through some polar coordinates here. Then once again, Thursday will be a review day for the final, and then Friday and Monday will be the final. Questions you have? All right, you have about 10 minutes here. The rest of the time is yours. You should be able to get through some of the graphs.